We'll be doing refractions at a spherical surface today. These are the answers for today's questions. Questions 1. Figure shows a 60 cm long glass rod which has convex ends with radii of curvature R1 and R2, which are 4 cm and 6 cm respectively. The refractive index of the glass rod is 1.5. An object is placed at a distance 20 cm from the left end of the rod. Determines the positions of image when the object is observed from the right side of the rod. How to find the positions of the image? Now, you have only one equation for refractions at spherical surface, which is n1 over u plus n2 over v equals to n2 minus n1 over r. So now let's look at the diagram again. Now, since there are two curved surfaces in between the object and the eyes, the object will then undergo refraction twice before it reaches the screen. So as you can see here, the surface that is closest to the object, we call it as a first surface, first refracting surface. And the one that is further away from the object, we call it second refracting surface. Before we apply the equations, the most important is to determine the sign convention. So now let us look at the diagram again. This is a diagram. So this is the first refracting surface. According to the questions, the object is located 20 cm in front of the refracting surface. So we have u equals to 20 cm. In front of the refracting surface, we call it n1. And then behind the refracting surface, that would be our n2. The last thing that we should do is to determine the sign convention r. Now, if you look at the shape of the refracting surface, it is bent towards the object 1. So in this case, we say it is convex towards the object. Therefore, R1 is positive 4 cm. So now that we have everything needed, let us apply the equations n1 over u plus n2 over v equals to n2 minus n1 over r. Substitute the values into the equations. We now have v equals to 20 cm. So if you look at the value, v is equals to positive 20 cm. It means this image is located at a distance 20 cm behind the first refracting surface. Now let us continue with the second refracting surface. Before we look at the second refracting surface, let us recall what happens in the first refracting surface. So this is a diagram for first refracting surface. And according to the calculation, image is formed at positions 20 cm behind first refracting surface. So when it comes to second refracting surface, we are going to use I1 as our O2. And this O2 will be used to determine the object distance. Remember, you cannot use V1 as your U2, okay? Because object distance is defined as a distance between object and the refracting surface. So in this case, we still don't have U2 yet. So now let us calculate U2. So if you look at the diagram, U2 is equals to 60 cm minus 20 cm. Therefore, U2 is equals to 40 cm. Okay, so now that we have U2, we are going to determine where is our N1 and N2 now. So N1 and N2, okay, we don't look at the positions of O2. The only purpose of O2 is to determine the object distance U2. Other than that, it has no other function. So in order to determine where is our N1, where is our N2, and the sign convention for the second refracting surface, we still have to look at the original object 1, because that is where our incident light is coming from. Since O1 is located on the left-hand side, therefore the left-hand side of the second surface would be our N1. So now my N1 is equals to 1.5, and the right-hand side of the second refracting surface would be N2. So N2 is now equals to 1.0. Remember, N1 and N2, you determine the positions according to the positions of the original object. Okay, so one last thing before we proceed to the calculation is to determine the sign convention for R2. So in this case, if you look at the diagram, this second refracting surface is now concave towards O1. So in this case, we are going to say R2 is equals to negative 6 cm. Now that we have all of the information needed, let us apply the equation for refractions at a spherical surface, N1 over U plus N2 over V equals to N2 minus N1 over R. Substitute the values in the equations, you will obtain V equals to 21.8 cm. And once again, the positive value indicates that this image is formed behind the refracting surface. But since you are doing the calculation for a second refracting surface, therefore we say this image is located at 21.8 cm behind the second refracting surface. Questions 2. A small flaw is found inside a crystal ball of radius 20 cm. The flaw is situated 5 cm from one end of the ball as shown in the figure below. Where does an observer see the image of the flaw? To find the positions of the image, first we need to know where is our object and under how many times refraction in this case. So even though you are given a sphere, but since the object is located inside the crystal ball, therefore it undergoes refractions once only. So if you look at the diagram, since the question asks you where does the observer see the flaw, therefore in this case, this flaw would be acting as our object. So the flaw is found inside the crystal ball. So like I mentioned just now, it just undergoes refraction once only. And which surface are we going to use? You look at the crystal ball. The surface that we are going to use would be the surface located in between the object and the observer. In this case, it's here. So this is the refracting surface that we're going to use. And if you look at the shape, it is concave towards the object. Therefore, we say R is equals to negative 20 cm. Before we proceed to the calculation, as usual, we need to know what is our object distance. Given diameter is 40 cm, so the object distance would be 35 cm. And once again, don't forget, we need to determine where is our N1 and where is our N2. Object is located on the left-hand side. So the left side of the refracting surface would be our N1. In this case, this N equals to 1.5 would be our N1. And then the surface that is closest to the observer would be our N2. So now that we have everything that we need, let us proceed to the calculations. So let's apply the equation for refractions at spherical surface. Now substitute the values into the equations and you will get V equals to negative 56 cm. When you have a negative V, then it means the image is located at 56 cm in front of the second refracting surface. That's all for today. I will see you all again tomorrow.